Hey guys, today I'm going to teach you all about inequalities. By the end of this lesson, you'll be able to compare and contrast equations and inequalities and graph inequalities on a number line. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. When we get started looking at the word inequality, you'll see something in the word inequality that looks familiar to you. It should be equal. You should see the word equal in the word inequality and realize equal means same. That's the equal sign. However, whenever you have that root word in front of it, that means not, so not equal. So when we look at inequalities, we're looking at things that are not equal or are not the same. But in this introduction, I want to get started with just a review of what an equation is before we look at what inequalities are. So an equation uses an equal symbol to show that both sides are equivalent. Here's some examples of a few equations we know to be true. 2 plus 3 equals 5. We could say x equals 5. We started looking at when one variable equals 5. We also could look at it like a two-step equation where 2 plus x equals 5. All of these are equations because they have an equal sign, and we know that this side is going to be the same as the other side. So the side on the left equals the side on the right. They are equivalent or same. On the other hand, an inequality shows that both sides are not equal. Remember that word in means not, and it has the word equal in it. So an inequality will be using different symbols than an equation. There's actually going to be 5 symbols we need to know. The greater than symbol, the greater than or equal to symbol, the less than sign, and the less than or equal to sign. And then finally, like we've already seen, the not equal to is like an equal sign with a slash through it. It means that it's not the same or not equal. Here's some examples of when you might see an inequality sign. For example, when we look at the numbers 5 and 7, we know that 7 is greater than or more than 5. So we would use an inequality symbol to show the relationship between the 5 and the 7. That's what's going to go in the blank here. So go ahead and take a second and think which symbol belongs in the blank. Is it this one or this one? The correct answer is going to be this one. This is the less than symbol. 5 is less than 7. One thing that my students have a hard time remembering, though, is how do you know which one to use? It's something that I also used to struggle with. How do you remember which way to point your arrow? Here's an easy way to remember this. I always look at these little symbols like alligators. I don't look at them like arrows or like greater than or less than signs. I look at them like alligators. An alligator with its mouth wide open. So this is an alligator with its mouth open, and he's got teeth. This is an alligator that always is hungry and wants the most food it can get. An alligator is going to always want to eat the bigger number. An alligator is so hungry and wants to eat the bigger number. So when I think about this symbol that goes in the blank, I'm going to want to choose to eat the 7 because it's bigger. So always imagine an alligator with its eyes and its big old pointy teeth, and it's facing the number it wants to eat. It's going towards the number it wants to eat, which is always going to be the greater number. Let me show you another example. So this is a picture of my mom and my little cousin October, and they're making ornaments. They're making these homemade ornaments, and it says on the box that you must be at least 2 years old to make these ornaments. You've probably seen a message like this on a box or for kids where it says like you should be 7+ years old to play with this toy, or this game is recommended for 13 and up. You might also have seen this on like parks or rides at the fair where it says you have to be at least this tall to ride this ride. This is the same sort of example. So if you must be at least 2 years old to make ornaments, we can write an inequality to represent this statement. One easy way to think about this is to use these people as examples. This is my mom. Her name's Pam. So I'm going to use a P as the variable to represent Pam. Pam has to be at least 2 years old. She's obviously older than 2. Obviously. She has to be older than 2. So I'm going to write a 2. And I'm going to think about what's the inequality symbol that goes between these. Remember, it's like an alligator, and it needs to eat the bigger number. So P needs to be greater than 2, or Pam needs to be older than 2. So I'm going to think about like an alligator that's eating Pam, eating the bigger number. Don't actually draw the alligator on your final answer, but if you need to, do it and then erase it. I don't want to say that on your final answers, but if you need to, you can go ahead and do that. So P needs to be greater than 2. However, October, here I'm going to use an O to represent her. She is 2 years old. Can she play with the Play-Doh ornaments? Can she make these ornaments? Yeah, she has to be at least 2 years old. So she can still be 2. This is whenever you use an inequality symbol that's greater than or equal to. That means that there's going to be a little line underneath of it. That little line is like half of an equal sign. If you have to be at least 2 years old, you can be 2, like October, or you can be older than 2, like Aunt Pam. So this symbol is useful for things that could be greater than or equal to. And just like the last example, we want to think about this like it's an alligator, always facing and eating the bigger number. And we want to use these inequality symbols with an equal sign underneath of it if it can be this number also. So let's look at some examples. I want you to try these by yourself. For these examples, you're only going to want to use the greater than, the less than, or an equal sign. So go ahead and check these out by yourself and then press play when you're ready to check. Okay, so by now you should have gone through these. I'm going to go through them really quick for you. I'm just going to pop the answers on the screen. Ready? Boom. Couple things you might have got stuck on. One is these negatives. Remember, if it's closer to 0, it's actually a greater number. So -2 is greater than -3. Another one you might have gotten stuck on was D. 6.1 and 6.10 are the same because there's an infinite number of zeros after the 1 here. And then I just wanted to point out this one, because this one here, 12.4 is like $12.40. This one's like $12.04. 40 cents is greater than 4 cents. That's why this is greater. If you have trouble with these, I want you to think about the alligator. I want you to remember that there's an invisible eyeballs and teeth on these alligators, and they're eating the bigger number. That's how we know which way to point our inequality symbol. Another important thing I want to show you about inequalities are some key vocabulary words that go with each one. So like you just saw in the last example with Aunt Pam and little October, was that she has to be at least 2 years old to play with it. That's where you see at least and you see the greater than or equal to sign. I want to make sure that you have this down. So either write this down, take a picture of it, screenshot it, whatever. That way you have this at hand to look at for clue words. You're going to see these clue words a lot because this is a really good example of a real life math problem. So on these two examples, you're going to see something that says write a verbal description to represent the inequality statements below. A verbal description means you use what we just learned with these key vocabulary words to write what this means. So on this example, you can say 6 is less than or equal to x. That means that x is all of the numbers that are greater than or equal to 6. So x could be 6, x could also be 7, 8, 9, 10, and so on. X could be any of those numbers. Because remember, a variable here, like x, represents an unknown number or a number that's changing. This one could be any number that's greater than 6. I also want you to notice that you probably heard me just flipping it around just without even thinking about it. And that's because this is 6 is less than or equal to x, but also x is greater than or equal to 6. You can flip it around. So as long as you have the x being eaten by the alligator, you could write it backwards. You could write it x is greater than or equal to 6. Notice that the inequality statement did not change. Even though the inequality symbol switched directions, the x is still the bigger number. It's still getting eaten by the alligator, just like here. Either way you write it, the inequality statement is still true. Go ahead and take a second and write an inequality statement for this one, and then press play when you're ready to check. So when you read this, moving left to right, y is less than 0.5 or 1/2. So you see here, y is less than 1/2. That's the very first thing you can write, and that could be all you write. That would be fine. I also wanted to point out that you can write it this way. You can say 1/2 is greater than y. If you write the inequality statement like this, this is the exact same thing as this. So y could be any number that's less than 0.5. That means y could be 0.4, 0.3, 0.2, and so on. Y cannot be 0.5 because it's not got an equal sign underneath of it. It's not a less than or equal to sign. It's just a less than symbol. It also can't be 10 or 12. It can't be huge numbers because it's less than. So anything less than 0.5 will make this inequality statement true. So when you're given inequalities, you're going to want to use the variable as the starting point when you're reading them. That's going to be really important and helpful whenever you're graphing, or whenever you're reading them because it makes it easier. So let's just practice that by looking down here and seeing whether each value makes a statement true. So on number 1, it says k, that means just some number, plus 8 is greater than or equal to 19. If k is equal to 11, is this still true? So what we're going to start by doing is substituting. We're going to take this 11. We know it's k, so we're going to plug it in for k in the inequality. So is 11 plus 8 greater than or equal to 19? 11 plus 8 is 19, and there's an inequality symbol that has an equal sign underneath of it. So I know that 19 could equal 19. So yes, that is true. This works, and it makes sense. The next statement says 12 is greater than f. You can also practice writing this as f is all numbers that are less than 12. It's the same thing because the inequality is like an alligator eating the 12. So as long as it's eating the 12 here, you can flip it around. If f is 3. So is this true if instead of writing an f, I wrote a 3? So is 3 less than 12? Yes, that is true. So you can put a check mark, you can write true. This value for f makes the inequality true. Number 3 says 3 is greater than d. And again, we're going to want to practice using the variable as the starting point. So we can also say d is less than 3. So 3 is greater than d, but also d is any number that's less than 3. If d is 3, is this inequality true? No, this is false. That's because there's no equal sign here. This is saying 3 is less than 3. You know that's not true. 3 is equal to 3, so there has to be an equal sign somewhere, whether it's a half equal sign or a full equal sign. Go ahead and try the rest of these by yourself, evaluating the inequality for the variable they give you and the value they give you. Just plug it in and see if it's true. Press play when you're ready to check. So I just went through each one of these and put a check if it was true and an X if it came out to be false. So for each one of these, I just wanted to remind you that it's easy when you do ones like this, like number 5, because it's just one operation being done. You put a 22 in for B and it's just 22 minus 8 can be done. So you do that and then you get 14. However, on one like number 6, 7, 8, and 9, you have 2 operations being done. This is examples of two-step inequalities. It's 6x plus 5, which means times when you see a number next to a letter. Times, then add. So you see 6 times 5, then add 5. That's how we get 35. Same for this one. If j equals 5, you put 5 in for j and multiply 2 times 5. That's how we got 10. So just so you know, that's how we do this. We do the same process even if there is more than one step being done. These are examples of one-step inequalities. These are examples of two-step inequalities. These ones like number 2 and number 3, there's not even any steps being done. They're just regular inequalities that are in a single variable. So we can actually go ahead and graph those. When you have inequalities that have just one variable, the inequality symbol, and a number, you can graph them on a number line. And I want to show you how, but first let's remember something we already have seen before you may not have noticed. Let's look back at that vocab sheet. So hopefully, like I said, you took a picture of this, screenshotted it, or wrote this down, and you saw the values included or the values not included. You have a closed bubbled in circle, and you have an open circle that's not filled in. Here's where this becomes important. The closed bubbled in circle means that the value's included. You use this bubbled in circle whenever you see greater than or equal to signs or less than or equal to signs. The key is the equals. If you see a little equals in the inequality symbol, you bubble in the circle. So when you see over here, x is less than or equal to 5, that means we start at the 5, just like you would start with any graphing numbers on a number line. And instead of putting an open circle, you're going to put a bubbled in circle. Let me show you that again. We have a 5, we'll start at the 5, and we have an inequality symbol that has an equal sign underneath of it. That means that we're going to start at the 5 and have an open circle that gets bubbled into a filled in shaded circle. That's because x is all numbers and it includes the 5. There's one extra step to this. Since x is all numbers that are less than 5, we want to also shade. So when you graph inequalities, you're going to want to shade all the numbers that that's true for. So if it's numbers that are less than 5, I'm going to want to shade these numbers. 0 is less than 5, 1, 2, 3, 4. etc. Those are all numbers that are less than 5. So I start by bubbling in at the number if it's got an equal to sign underneath of it, and then I shade. However, there are some cases whenever you don't bubble in, and that's if you have a less than or a greater than sign. So for example, let's pretend like this does not say x is less than or equal to 5. Let's pretend like it just says x is greater than 7. If this is the case, then I start at the 7, but instead of bubbling it in, I use an open circle. That's because it's not included in it. It's around 7, but it's not actually 7. So once again, I go to the number line. X is any number that's greater than 7, so I start at the 7, and I put a circle around, but don't fill in the 7. That's because this is an inequality symbol that's just greater than. Then I want to shade one side of the number line, either the left or the right. I want to shade all numbers that are greater than 7. So I'll look here and I think, okay, is it going to be a 9 or a 5? If it's a 9, that works. That makes this true. If it's a 5, it's not true. So I want to shade the side that is true or that works. So anything that gets included, I shade that side of the number line. This is how you graph an inequality. So here's some examples for you to practice. I'm going to go ahead and pause the video now. And then whenever you press play, it's going to have all the answers on here. So try these by yourself first. Then press play when you're ready to check. All right, so here are your answers. Hopefully you got at least 4 of these right. This is an example of following instructions, looking at the definitions, looking at the chart, whatever, and then applying it to the graph. There's only 2 things you need to remember for this. One, is it an open circle or a closed circle? Use an open circle if it does not have the equal to sign. Use a closed circle if it has the equal to sign underneath of it. I'll remember that because I think, okay, if it's an open circle, it's around these numbers, but it doesn't include those numbers. If it's a closed in, bubbled in circle, I think about it like, okay, it's that number, just like you would graph it if it was an equal sign. The other step you need to remember is which side am I shading? The way you remember that is to plug in some numbers and then see if it works. So for example, on number 11, I could plug in 11, I could plug in 13. The number that works for this is 11. So I shade that side of the number line. It's that simple. 2 steps. Is it an open circle or a closed circle? Which side of the number line do I shade? All right, guys, that's it. If you made it to the end of this video, please put your goal for the week in the comments. Today we learned all about inequalities, and we got that basic introduction. So now you should be able to compare and contrast equations and inequalities and graph inequalities on a number line. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.